In this problem, we're going to take a look at a fairly complicated polynomial division problem where they ask you to factor the polynomial, and they give you this piece of information saying when you plug in a 1 for x, you do get a 0 of the function. And what that means is, that means x minus 1 is a root of the function. What they're asking you is that, well, what's left? If this is a factor, and we pulled it out, I hope students remember that when you set this factor itself equal to 0, you're finding that one root. And really, if I solve this, it's x equals 1. That's what they're telling me. So in kind of a backwards fashion, f of 1 is 0. That means when I plug in x equals 1, the whole function comes out to be a 0. Okay, that means this is one factor. And really what the question is asking you, factor the polynomial, if I have this piece here, they're asking, well, what's this other piece? What's it look like? Really, since this is one polynomial with some x squareds and maybe an x and maybe a constant, I don't know, I just made that up. But they're saying this times this equals that big polynomial there, right? They're telling you if you break this out, what's left? What is this big polynomial that I just made up there? Well, really what they're asking you is you have to divide this big one by the root, or x minus 1. So I hope you understand that. And from that point forward, it just becomes a division problem. So I'm going to do the division problem now. Long division, 4x cubed minus 4x squared minus 9x plus 9. I write out my dividend, and then I write out my divisor, which is x minus 1. So when I divide that by that, I'm going to find what's left, and I'll see if it's factorable. Okay, so now moving into long division, what can I put here when divided by x is going to give me, or when multiplied by x gives me 4x cubed? Well, I think it's going to be a 4x squared. So 4x squared times x gives me the 4x cubed that I'm looking for, because we're going to subtract this whole thing. But don't forget, 4x squared must also be multiplied by minus 1, and I get a minus 4x squared. Okay. So now when I subtract this, 4x cubed minus 4x cubed gives me 0. That's why we did it. Minus 4x squared minus a minus. Well, this one here is really a plus, right? Two minuses make it a plus. So minus 4x squared plus 4x squared. Oh, that also gives me a 0. That's nice. Now I bring down a minus 9x. What it tells me is there's no term up here that has x in it. We don't need it. Because now I look at my next one. I look at minus 9x. What can I multiply by this that will give me 9x? Oh, I think it is a minus 9. If you're not sure, just take this right here and go minus 9x and divide by the first term of your divisor here. Divide by x. Oh, and I get the minus 9. It goes right here. Okay, I hope that works for you. Okay, but anyway, minus 9, now I multiply it by both. So I get a minus 9x. Oh, and I forgot to bring that as plus 9 from over here, right? That comes down here. Minus 9 times x gives me minus 9x. Minus 9 times minus 1 gives me plus 9. And I'm subtracting this whole thing. Minus 9x plus 9x, right? A minus and a minus is a plus. It gives me 0. Plus 9 minus a plus 9 is 9 minus 9. Oh, that gives me 0 as well. Folks, this is very unique. This tells me there is no remainder. These two things factor perfectly. So this huge polynomial here, the one in my original equation, this thing here, when I divide by x minus 1, I get this answer here, which means my factoring now looks like this. X minus 1 and whatever my answer was here, 4x squared minus 9. 4x squared minus 9. Now, if that was unfactorable, okay, oops, I probably shouldn't do that last part. 4x squared minus 9. If this piece here was not factorable, then I'd be done, because all they said was factor the polynomial if f of 1 equals 0. I've divided by x minus 1. Now I should be done, except that I quickly see here this is a perfect square and this is a perfect square. Whenever you have the difference of two perfect squares, it factors like this, right? It factors with a plus minus. This thing's still sitting out here out front, right? What's the square root of 4? 2. What's the square root of x? X. I can see that that's a perfect square. I can see that's a perfect square. It's 3. And so we should be able to see that 2x plus 3 times 2x minus 3 does give me what's inside these parentheses here. So I factored first by doing a long division, but I'm not done there because this can be factored further. So here's my final answer. They asked me to factor it. They did not ask you to find the roots. But if I did, I would set this set of parentheses equal to 0 and find a value for x. I would set this set of parentheses equal to 0 and find that value of x. I would set this set of parentheses equal to 0 and find that x, but we already know that one, it's 1. That's what we started with. This is a solution of the equation or a 0 of the equation, and so that's where this would go. They've only asked you to factor it, so that's your final answer. If you stopped here, you're not wrong. It's just not quite complete. Okay, hope that helps.